absolute legends. The conservation of matter and energy in physics class is something I remember a lot of professors talking about. Like all of the energies at the beginning have to equal all of the energies at the end right there, all the kinetic and potential electromagnetic energy. In chemistry, we do consider the conservation of matter and energy in a few different ways. In a balanced chemical reaction, or just in the chemical reaction between methane and oxygen gas, CO2 and H2O are going to be some of the products for a pure, clean combustion. Now, this is an informative reaction because it tells us about the products and the reactants, but it doesn't follow the conservation of matter because the number of hydrogens on this side is 4 and the number of hydrogens on this side is 2. So this is a possible reaction, but this is impossible to make any predictions on here. So if we do some balancing and say like, okay, what if we have 2 waters are produced and now we have our carbons are balanced 1 to 1, our hydrogens are balanced 4 to 4, and our oxygens, we have 2 oxygens on this side. What if we have another one? So this way right here tells us a formula that is predictive in the quantities required of matter that is for this reaction here. Now, the conservation of energy. This follows the conservation of energy as well. Consider how everything on the reactant side is neutral or overall in charge. Everything on the product side is neutral and overall in charge. So we start neutral and neutral. Here's an example of an unbalanced chemical reaction. Now I say unbalanced because it's unbalanced in the energy. We have 2 hydrogens on this side and 2 hydrogens on this side, but the charges are not balanced. On the reactant side, this is neutral overall. And on the product side, this has a +2 charge. So to balance this with matter and energy, if we add 2 negative electrons on here, this is more predictive into what Mother Nature's possibilities are with conservation of matter and energy. I hope this helps. Thank you.